Hi, welcome to part 13 of the video series about laws of motion. We have learned what the friction force is, then we have classified friction forces as a static and kinetic friction force, and at the end of the video, we have learned about the coefficient of friction. In this video, we are going to apply the theory we have learned in the previous one to solve some examples related to the friction force. Before we even start to solve these examples, let's make sure that we have already watched the videos about the normal force, as the friction force and the normal force are directly proportional. We are not going to explain how we are calculating the normal force in this video, as it will make this video too long. We may find the links for videos about the normal force in the description section below the video. We are going to start with simple examples and then gradually increase the level of hardness of questions. In the first example, we have a 5 kg object which is on a surface with coefficient of friction of 0.2. We are asked to calculate the magnitude of friction force. Unless it is not mentioned in the question that the object is stationary or at rest, by convention, we consider that the object is in motion, which means the friction force applied on this object is the kinetic friction force. Friction force can be calculated as coefficient of friction times normal force applied on the object. On a horizontal surface, the normal force is equal to product of the mass of the object and gravitational acceleration. Coefficient of friction is 0.2, mass of the object is 5 kilograms, and the gravitational acceleration is 9.8 meters per second square. The magnitude of the friction force experienced by the object is 9.8 newtons. In the second example, we are asked to calculate the acceleration of 5 kg object while force of 30 newtons pulls it to the right. The coefficient of friction is 0.2. We start the solution with drawing a free body diagram. Force of gravity is applied downwards, the normal force acting upwards. There is a force of 30 newtons, an applied force acting to the right. And then there is friction force opposing the direction of motion. As we are required to calculate the acceleration of the object, we start by writing the formula for the second law of motion. We consider the direction of normal force and force of gravity are balancing each other on a vertical axis. We consider the direction of the motion, which is to the right in this case, as positive direction. The net force is equal to applied force minus the force of friction. Friction force can be calculated by multiplying coefficient of friction and the normal force. The normal force can be calculated as mass times gravitational acceleration. While substitution, the applied force is 30 newtons, coefficient of friction is 0.2, mass is 5 kilograms, and gravitational acceleration is 9.8 meters per second square. The value of the net force is 20.2 newtons. Acceleration of the object is 4.4 meters per second square. We have chosen the right as a positive direction. As the value of acceleration is positive, its direction is to the right. In the last example of this video, there is a 5 kg object sliding or at rest on an inclined plane. Angle of inclination is 37 degrees and coefficient of friction is 0.2. The task is to calculate the magnitude of friction force for two different cases. In the first case, the object is at rest. In the second one, it is sliding down. Before diving into calculating friction force, let's calm down and draw a free body diagram. There are three forces experienced by this object: the force of gravity, the normal force, and friction force. In the second video about the normal force, we have learned how to split the gravitational force acting on objects on an inclined plane into its components. We do it by drawing two forces, with one of them parallel to the surface and the other one is perpendicular. Don't forget that in the exam, in a free body diagram, we either draw the vector which represents the force of gravity or its components. If we draw force of gravity and its components on the same free body diagram, we will be penalized by 1 mark. That's why we remove the vector representing the force of gravity from our diagram. Once we are done with free body diagram, we can continue with the solution. In the first part, we have to calculate the magnitude of the friction force on an object which is at rest. We know that the friction force applied on an object which is at rest is the static friction force. Also, we know that the magnitude of the static friction force is always equal to the magnitude of the applied force. While the object is at rest, the parallel component of the gravitational force is trying to move it down the incline. So, the static friction force is equal to the parallel component of the force of gravity. As we have learned before, parallel component of force of gravity can be calculated by mass times gravitational acceleration times sine theta. Mass is 5 kilograms, gravitational acceleration is 9.8 meters per second square, and theta is equal to 37 degrees. Friction force is equal to 29.49 newtons. On the other hand, if an object is in motion, the friction force experienced by it is the kinetic friction force. We calculate kinetic friction force by multiplying coefficient of friction by the normal force. On an inclined plane, the normal force is equal to the mass times gravitational acceleration times cosine theta. Coefficient of friction is 0.2, mass is 5 kilograms, gravitational acceleration is 9.8 meters per second square, and theta is 37 degrees. As a result, friction force applied on a moving object is 7.83 newtons. Splitting this question into 2 parts made it easy for us to solve it, as we became suspicious of question and easily realized that we have to apply different solutions for each case. In the exams, it is our responsibility to find out that either the object is at rest and it experiences static friction force, or the object is in motion and the friction force experienced by it is the kinetic one. In this video, we have learned how to solve some examples related to the friction force. In the next one, we are going to continue with another set of questions. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.